For more videos, visit forthesakeofeducation.com. Alright guys, let's do this problem that says the handle of the hammer is subjected to this 20-pound force, 20 pounds. Then find the moment that it creates about A. That's the first problem that we're doing. So what you gotta do is you find I'm gonna choose this to be the Y and this to be the X, so you gotta find the X and Y components. This is the Y component of the force. So F of X is equal to F cosine of 30. F of Y is equal to F sine of 30. So counterclockwise being positive, the sum of the moment that F creates about A is given by the X component, which is F cosine of 30 times 1.5, since counterclockwise is positive, but as you can see the X is turning this lever arm to go clockwise. This is negative. And then the other one is F sine of 30 times 0.4167. Now if you're wondering where I got these numbers from, 1.5 is 18 inches converted to feet, 1.5 feet, and 0.4167 is 5 inches converted to feet, 7 feet, already converted to feet. And this is also negative because the Y is turning this lever arm clockwise, so they're both negative. So you already got the force, so when you plug in the force you get that this is equal to negative 30.147 foot-pounds, or 30.147 foot-pounds going clockwise. And that is the answer for the moment that F creates about A. Now for the second part, they tell you that in order to pull the nail out, the force has to create a clockwise moment of 500 pounds per inch about point A. Then find the required magnitude of F. In other words, how strong does F have to be able to pull the nail out? So we're gonna convert 500 pounds per inch into pounds per feet, because the formula that I have right here is in pounds per feet, because I already converted the 1.5 and the 0.4167 from the inch values. And this you do this basically by dividing by 12, and you get that it's equal to 41.67 foot-pounds. So this is the moment that is required to be able to pull the nail out. So that moment we plug it into this part of the formula, we get 41.67 is equal to negative F cosine of 30 times 1.5 minus F sine of 30 times 0.4167. This 41.67 is also negative because our convention is that counterclockwise is positive, but they're telling you that this moment is going clockwise. They tell you right here. So basically what you do is you solve in this formula for F. You can do so by factoring F out and just dividing the rest, what you got left, into 41.67. So you solve for F and you get that F is equal to 27.64 pounds. So final answer for the force required to pull the nail that creates a clockwise moment of 500 pounds per inch. And final answer for the moment created by the 20-pound force applied at the hammer.
Please comment below if you want me to do any problems and I'll be happy to help. Thank you.